Hi children, welcome to your home school. This is your next session of your class 10 mathematics NCERT or CBSE syllabus. This is your second chapter, triangles. In our last session, we have completed up to exercise 2.3, 7 problems. Now we are going to start with the 8th problem, right? So let's see the 8th problem here. E is a point. What is the letter? Capital E is a point on the side AD. Okay, produced of a parallelogram ABCD. First thing what we need to do, let us draw a parallelogram. A, B, C, D. What is this, children? A, B, C, D is a parallelogram. Once again, let's read. E is a point. Do we have anywhere E? E not there. E is a point on the side AD. See, where is side AD? This one, right? On the side AD produced of a parallelogram. Oh, this AD line is produced. Okay, let us take here E. ABCD and BE intersects. BE means we need to join E to B. BE intersects CD at F. So let's mark here F. Show that triangle ABE is similar to triangle CBF. Children, try to understand the problem what given for us. E is a point on side AD. When it is produced, E is a point we need to take here, right? Side of a parallelogram AD when extended to a point E, then that E join B. So BE intersects DC at F. So what's your question? Prove that this big triangle is similar to the small triangle. How can we prove? Okay, first what did they give us? They have given us a parallelogram. So children, try to remember some points of a parallelogram. What do you all know? Opposite sides are parallel to one another. And interior angles of a parallelogram are equal. And any transversal drawn in between these parallel lines, right? So the angles are alternate to one another. These are all the points we should remember. Okay, let's start our proof. Given data. What is the data, children? Always we start our problem with a given data. Given A, B, C, D is a parallelogram. So still what did they give here? Okay, given ABCD is a parallelogram. And what did they do here? Produce AD to a point E. Okay. So produce AD to point E and join. And one more line. BE intersects DC at a point F. Okay. So still what they have given to prove. Construction you can write, children. Join that and this you can write. What we need to prove. Triangle ABE is similar to triangle CFB. Triangle CABE is similar to triangle CFB. We need to prove. So let's start our proof here. How do we start here? We know. We start our proof with we know. We know in a parallelogram, what do we know, children, in parallelogram? Opposite sides are parallel to one another. So I take this pair of sides. AB is parallel to DC. Okay, indicate like this. Okay, next one. And interior angles. Angle A is equal to angle angle C and angle B is equal to angle D. What is this? In a parallelogram, opposite interior angles are equal to one another. Let us consider. What shall we consider here, children? What the triangles we need to prove, that we will consider. Consider triangle ABE and triangle CFB. You can identify here, or you can take a small tiny rough figure. ABE and one more, what do you have here? FBC. Right? So now observe here, still something we need to find. I can say angle A is equal to angle C. Okay. Then again, I can say this one, angle A is equal to angle C and angle B is equal to angle F. So what is this, children? The angles between two parallel lines are alternate to one another. So for this, what I can say, this angle is equal to this angle. That means angle B of this triangle is equal to angle F of that triangle. So what you can say? Angle similarity criteria. These two triangles are similar. So once again, how we have started here, children? We know that they are parallel, and what we have said, angle A is equal to angle C. So that we are going to compare here in triangle ABE. Angle A, which angle? EAB. Observe here carefully. EAB is equal to, what is this angle here, children? BCF. Angle BCF. Okay. Reason you write, opposite angles in a parallelogram are equal. Opposite interior angles of a parallelogram are equal. Okay. So next step, how we can write this, children? Angle B. I will write ABE. Angle ABE is equal to, say this triangle, BFC. Angle BFC. How can you say? Alternate angles in between two parallel lines. Alternate angles in between two parallel lines are equal. So finally what we can say, children? Two corresponding angles of two triangles are equal. So in two triangles, corresponding two angles are equal. Then I can say by angle similarity criteria. What can you say here? Triangle A. What is the triangle we have taken? Triangle ABE. Now write with a symbol. Angle ABE is similar to triangle CFB. By what? How we are saying this, children? By angle similarity criteria. Angle similarity criteria, I can say that these two triangles are similar. So try to understand carefully. Just have a recap. E is a point. Produce AD to meet at E and join BE. BE is a line which is intersecting DC at F. Okay. So now observe which triangles you need to prove. This triangle and this triangle. So how can I prove? In a parallelogram, opposite angles are equal. And if in between two parallel lines, if a line is drawn, the alternate angles are equal. According to that condition, in these two triangles, you are able to write here two angles are, corresponding angles are equal. If they are equal, then the two triangles are similar. Okay, let's see the ninth problem here. Ninth one, children. In figure, ABC and AMP. Observe here. ABC, right triangle. AMP, right triangle. Can you observe two right triangles here? Okay. Are two right triangles right angled at B and M? Respectively, prove that triangle ABC similar to triangle AMP. This right triangle is similar to this right triangle is your question. So, in order to compare, what did I do here, children? I have taken out the two triangles outside. So, look here, ABC as it is I have drawn here. So, now this sleeping right angle triangle. So, let's make it to stand up. So, how do you make it, children? So, right angle is this side. Similarly, you should bring this right angle also here. How? Lift this P up and make it here. So what happens here? If you lift your P, it will be like this. Then this will be right angle. PAM, lift this right angle and keep aside. See here how you need to compare. Actually, this is a technique to do correctly in your geometry. So directly if you see in the same figure, so comparing will be difficult. If you do like this separate right triangles, then you never do any mistake. Okay, try to understand here. So like this only we can take if you want, but little you may feel difficult. So lift this P up, make it to stand and place here. So as it is this right angle place here, it will be PAM. Okay, now compare the two right angles, children here. Angle B, angle MY, 90 degrees, they are right angle. And one more I can see, can you observe? Angle A, common angle. So, these two are common and these two are equal. What I can say by angle-angle similarity criteria? These two triangles are similar. First proof, yes, over. So, coming to your second one. So, if any two triangles are similar, what is the condition here? Angles must be equal and their ratios are in proportion. First, I am saying these two triangles are similar. If they are similar, then their ratios are in proportion. Directly you can equate their ratios. Problem already solved here. Let's do here. See, don't by heart this geometry. Right? Try to understand these triangles, then you will enjoy this chapter. Given data, children, here I have started here solution. Given data ABC and AMP are two right triangles where they are right angle at B and M. What I need to prove, we have written here. So now how do we start our proof? Consider. What we need to consider, children? What we need to prove? These two triangles, right? Consider right triangle ABC. Observe right triangle, right? This is a symbol and make sure that central letter should contain right angle. Right triangle ABC and right triangle AMP. There also central letter should contain right angle. So, right angle triangle ABC and right triangle AMP. So, in these two triangles, how we compare? Never try to compare this one first. Okay. So, look here. If you are comparing first this triangle, compare all the angles or sides. First this side towards LHS side and other triangles towards the right hand side when you are comparing. How you do mistake now, children? Angle A is equal to angle A common, you write, and immediately angle M is equal to angle B, you write. Please don't do like that. When you are comparing one particular triangle, try to write all its angles towards one side, then other triangle towards the other side. How do we start our proof, children? By considering the two right triangles. Consider right triangle ABC and right triangle AMP. How do you start your consideration here, children? If you take this triangle, write all the angles or sides this side. And if you take this triangle, this side you write. So one this side, one that side, don't interchange. Okay, follow one order. So now right angle triangle ABC, I am going to compare. What is that? Angle B is equal to angle M is equal to 90 degrees. Right angle, it is already given. You can write in brackets if you want. You can write given. Okay, then one more. Angle A is equal to angle A. Angle A is equal to angle A. What is that reason here, children? Common, it is a common angle. So therefore what you can say? Right triangle ABC is similar to right triangle AMP. Over, first proof already completed. But hold on, I have written only shortcuts. While you are practicing or understanding, you can use only shortcuts. Angle B, angle M, angle A, angle A. But while writing in exam, angle B, little write this letter and this letter. Angle ABC, angle AMP. And angle A, you can write it as angle CAB is equal to angle PAM. Okay, this is your first proof. Coming to your second proof. So what you need to prove here, children? The ratios are in proportion. We know here. What do we know? We know both the triangles. If you want, you can write normal triangle also. Triangle ABC is similar to triangle AMP. Okay, we know by above proof these two triangles are similar. If they are similar, if they are similar, then the ratios are in, proportion. According to this condition, if these two triangles are similar, then the ratios are in proportion. Now equate the ratios here, children. That is AB by AM, corresponding ratios. AB by AM, BC by MP. BC by MP is equal to one more, CA by PA. But in your question, only two ratios asked. What is that? CA by PA is equal to BC by MP. So, next step, what you are going to write, children? Just write only these two ratios. Why? They have asked to prove only these two ratios, no? So, finally, hence it is proved. That's it. So, three ratios asked, three ratios you can write, or any other two ratios asked, only other two ratios write and say hence it is proved. So, quickly let's have a recap here. They have given two right triangles, whereas right angle and one common angle we know. By comparing these two triangles, I can say that two triangles are similar. If they are similar, according to second proof, the ratios are in proportion. 10th problem here, CD and GH. What are those? CD and GH are respectively the bisectors of angle ACB. Okay, angular bisectors. What does they do, children? They divide the angle into two equal halves. Okay, so angle ACB. So let me draw a triangle here. What is the angle here? It is dividing, let it be C, right? ACB I will take. Okay, then one more angular bisector. What is that? G. Okay, and this will be EGF. So, angular bisector, what does it do, children? It divides the angle into equal halves. So, that means, so let me consider here angle 1, angle 2. That is, angle 1 is equal to angle 2. It is dividing equally, right? So, next one. What is the another angular bisector? EGF bisected, and what is the letter here? GH. Okay, here also same manner, 3, 4. That means angle 3 is equal to angle 4. Angular bisector, what does it is doing, children? It is dividing the angle into two equal angles. So now let's read here. Such that D and H lie on sides AB and FE. Okay, observe here, children, they did not give us EF. So let's change here. FE. Okay. So why we are changing? Look here like this. lie on the sides AB and FE of triangle ABC and triangle EFG respectively. If triangle ABC is similar to triangle FEG. So what is your question? They are saying that the two triangles are already similar. If they are similar, what I need to prove? Some ratios are in proportion and some tiny triangles are similar. We need to prove. So first thing what we need to do, we'll observe in the figure. So what is this? CD GH, okay. AC FG means first one I need to prove these two triangles are, they already said they are similar. We need to prove these two triangles ratios are in proportion. First concept, children. Second one, where is DCP? Here. And HGE, this one. Second concept, this triangle and this triangle similar, we need to prove. Third question, triangle DCA, this triangle, and HGF, this triangle. These two triangles are similar, we need to prove. Okay, try to understand the question here. They have given us two triangles. Okay, from the vertex or anywhere you can take this angular bisector, you may take here also, no problem. A, B, C, and you can bisect your angle like this. Don't by heart the figure. Okay, so draw two triangles. See the letter or the what is the angle which is to be bisected. So there you bisect and mark the points D and H. Then what you are going to do? Then understand that angular bisector makes these two angles equal. Angle 1 equal to angle 2, angle 3 equal to angle 4. Okay. So now let me write the first one we need to prove. Look here. So how do we start our proof here? Solution. First, given data. What is a given data, children? You just write this given data. Given these two are the angular bisectors. CD and GH are the bisectors of those two angles such that D and H lie on the sides. AB and FE of triangle ABC and EFG. Children, please write these two statements in the given data. There is no limited spaces there here. So next, and what they have given, if triangle ABC is similar to triangle FEG. So the two triangles are similar. They are already saying that these two are similar. If they are similar, what do we know? The corresponding angles are equal and the corresponding ratios must be in proportion. Right? So these two triangles, angles are equal means which angles you can say? Angle A, angle F, angle B, angle E, angle C, angle G. Corresponding angles are equal. Immediately by reading that similarity, you should get this word. And one more, AC by GF, AB by FE and BC by EG are in proportion. What to prove? You write this line in the step. Then next, let me start here. Proof. In proof, I'm going to consider first one. What I need to prove? CD by GH is equal to AC by FG. So observe these ratios, children. Only that triangle you try to consider. So now consider. What are the two triangles here? ADC and triangle FHG. Observe this triangle and this triangle you are comparing in order to prove this ratio. So now when you are comparing, what you can say? Given, by given data, what do I know? The two triangles are similar. If they are similar, I can write angle A is equal to angle F. Will you accept? Angle A is equal to angle F. This is already given data. Then one more I need to prove. How can I prove one more? Observe here carefully. So, angle 1 is equal to angle 2. Right? Or I may write it as angle ACB is equal to angle FGE right? I want only half of the angle. I don't want complete angle. Understand the concept here? I don't want complete angle. I need only the half of the angle. That means let us do half of angle ACB is equal to half of angle FGE. What is half of angle ACB? It may be angle 1 or angle 2. Any one you can take. When you are proving this side triangle, you take angle 1. When you are proving this side triangle, angle 1 equal to angle 3 you take. Suppose if you are considering this triangle to prove, up to here common. Half of it, which half you consider? It depends on your question. Okay. So now I am going to consider half of this. Half of angle ACB. I will consider only this part. That will be angle ACD is equal to angle FGH. Okay. Observe here carefully. What did I do here? In order to equate the corresponding angles equal. Why? The two triangles are already similar. So what is given? The two triangles are similar. Therefore the angles are equal. One pair directly I can write. Then another pair. I don't want a complete angle. I need only half. So now what you can write here? The same thing you can consider here. Angle ACB is equal to angle FGE. And now I need half of this angle. Angle ACB is equal to half of angle FGE. Which half we are considering, children? This half. That is, if you want, you can write angle 1 also you can write. But I try to write full form, children. Angle ACD is equal to angle FGH. Okay. So now what I can say? This is angular bisector. This is also given and this is also given. These two angles are equal. What you can say? The two triangles are similar. Which two triangles? It's not complete triangles. Part of the triangles is our question. So therefore, triangle ADC is similar to triangle FHG. By what I am saying these are similar? Therefore, by angle similarity criteria. So on you complete this. Angle similarity criteria. These two triangles are similar. If they are similar, what you can say now? If they are similar, the corresponding ratios are in proportion. So let's continue our problem here, children. If they are similar, what I can say? I can equate the ratio, that is AD by FH is equal to DC by HG is equal to CA by GF. But what is the ratio we need? CD and AC. Only these two we need. Finally, if you want, you can write CD or DC. No problem. Both are same. CD by GH is equal to AC by FG. Interchanging, no problem, children. Nothing will happen. Therefore, first sub question. Hence it is proved. Okay, this is the way we do your first question. Second question. Look here, second question. What is your second question? Triangle DCB similar to triangle HGE I need to prove. This is the question, children. Don't consider they have given. This is the question we need to prove. Now, second question I have taken here. How can I prove this? First, let me consider the two triangles, DCB and GHE triangle. Okay. So, now write here, consider the triangle DCB and triangle HGE. DCB and HGE. So same manner, no change. Now this side triangle you are trying to compare. So that is angle B is equal to angle E. Why? Given. Angle B is equal to angle E. How we are saying this? Given the two big triangles are similar. If they are similar, corresponding angles are equal. According to that, I have equated. Now comes here. This not given, this given. What is that? Same manner, angular bisector. So again, you write the two steps here. So given, what they have given, children? Angle ACB is equal to angle FGE. Okay, I don't want complete angle here. I need only this part. Observe here carefully. Only angle 2 I want. I don't want angle 1 here. Angle 2 needed means half of it again. What is half of angle ACB? Half of angle FGE. Half of angle ACB, anyone you can take, but I am taking this triangle, right? This angle I will take. That is angle BCD. Angle BCD is equal to EGH. Angle EGH. So now, this is also given, children. Now, angular bisector, it is divided. Then half of that angle, then those two angles are equal. By angle-angle similarity criteria, by AA similarity criteria, I can say triangle DCB is similar to triangle HGE. Yes or no? The two triangles are similar. Coming to your third one, observe carefully. What is your third one? DCA HGF. Same, no? So for the third one, what you are going to do? From here, look here. Third one, again you rewrite from here to here. So look here, consider the triangle ADC and consider the triangle FHG. Same pattern. What we have done, instead of this, they would have given this as a first question. That means we would have done this one. Then if this is second question, then from here we can just write the ratios. But they have given first this question. So I already have done your third answer also here itself. So what you need to do? First you solve this. Second you solve that. Again take the third sub question. Look here, third sub question. What you are going to take? Triangle DCA similar to triangle HGF I need to prove. For that, consider the two triangles, compare the corresponding angles and say equal, and take the angles, angular bisectors, half of it, and then say they are equal. If two corresponding angles are equal, then I can say that the two triangles are similar. By which criteria? Angle similarity criteria. I can say the two triangles are similar. If they are similar, then the two triangles, by angle similarity criteria, I can say the two triangles are similar. Okay, children, with this we are going to end our session today. So try to practice these problems at least 2 times. Now itself, after seeing the video itself you need to do, then you will be perfect. Thank you, children. Thank you all.